Hi, I'm Jan Ozer. I'm chatting today with Daniel Summer, who is just launching Codec Market, the world's first AI-optimized cloud acceleration solution. Hey, Daniel, thanks for joining me.
Sure thing, Jen.
What is an AI-optimized video cloud acceleration solution?
Well, simply put, we're leveraging an innovation that actually came out of Netflix, which allows a machine to see like a human, which is a huge breakthrough in video transcoding, leveraged to great extent by Netflix and now a bunch of others to adjust the myriad parameters available with video transcoding pipelines uh, to get right at the threshold of what a person will perceive as a good quality video. Prior to that, you really had to either handle every video individually or sort of take a crapshoot and choose a bit rate that would be higher than would generally be necessary to encode a video. So leveraging AI for human vision capabilities is really at the root of what we're doing.
Okay, so what technology is that? Is that human vision in quotes, or
Human
what is
vision.
it?
So I'm referring to the technology that was open sourced by Netflix, VMAF. So
Okay.
the model that was produced by VMAF is a incredibly useful tool that can be used in a variety of different ways. So Netflix published a method that they use for leveraging that for their encode ladder. But what we're finding is there's quite a bit you can do with it.
VMAF, as we know it, is a video quality metric that you apply to an encoded file. You compare it to the original. It's slow, very accurate. It correlates well with human perception. But how do you use that in the context of an encoding facility?
Okay, great question. So I can first speak to the way that Netflix used it in their reference example that when they published it initially. Um, and this is going back a number of years, but um, in Netflix's case, what they're able to do because they have a relatively small number of videos that they want to extract the absolute maximum quality out of, they're able to use VMAF to do a whole bunch of different encodes, measure the VMAF on all of them at a variety of different bit rates, and then choose an optimal one to use in a ladder on a scene by scene basis. Doing that is incredibly expensive.
Mhm.
If you're charging for the viewers in when you're Netflix and you're charging for the views of these videos, that works. And Netflix, it's well known that they use cloud major cloud compute provider, and they are a very big consumer of compute, probably one of the larger ones uh, prior to the AI revolution more broadly. But I had no idea when I heard from some of my friends at this large cloud provider how it was that Netflix was spending tens of millions a month on their encoding, on just the compute for the encoding. That blew my mind. And this was before they open sourced it. So what, as it turns out, it's worth it to spend a lot of time doing these quality metrics. And in that method that they described, they're using it essentially to optimize video encoding. The question that we've set out to answer is, can we leverage the benefits of that approach at more reasonable price points for folks that don't have spent tens of millions of dollars a month to spend on encoding? And it turns out the answer is yes.
Okay, so are you VOD live or both?
VOD. We can accept live video as an input stream, but we're not transcoding live.
Okay.
We do encode much faster than real time because we have a very distributed process, including multi-ladder, multi-codec, multi-bitrate, multi-codec, but we are not doing live encoding.
Is the AI that you refer to all VMAF, or do you have any internally developed AI as well that goes into the encoding? Because VMAF not going to help you with encoding. It's gonna help you pick the best bit rate for a particular scene at a particular resolution, but it's not going to make the encoding more effective. So do you have any AI that's doing that?
I would disagree with you, and I'll tell you why. It, it is, as you know, with encoding, there are many different parameters one can modulate. And that's not just within a codec. Every codec that I can think of has a dozen or more parameters that can be modulated, some of which you don't want to change within the spec that you're trying to produce, but there's many that are adjustable, most obvious being bitrate, that have an impact on quality. When you integrate a feedback loop of okay, I'm going to try this. Did it make my video look better or worse? Did it make the bit rate higher or lower, right? If you can integrate that into every one of those parameters in a meaningful way, you can do adaptive encoding that optimizes any codec. Put another way, we're using VMAF AI for the VMAF AI model for rate control, but also other things like adaptive preprocessing, and we're leveraging things like ASIC encoders now also, which historically do a lousy job of rate control. So just as simple as that, just using VMAF to determine where that threshold is to hit the sweet spot of a quality target has a tremendous impact on encoding. And it's not just within the codec. So do we have some magic model that's not VMAF? No. Are we using that in a clever way to get more out of it using a bunch of other technologies? Yes.
So you talked about adaptive preprocessing. What is that?
Sure. So one thing I learned working on MPEG-1 encoding back in the 90s for CDIs, when you have a very limited number of bits to use, you don't want to spend those bits on any sort of random noise. So a great application of adaptive preprocessing is, I would categorize as grain management. Now, depending on the content type, you may or may not want to do this because some directors will use noise and grain for dramatic effect. So when I say adaptive preprocessing, there are filtering types that can preserve some of these looks in a way that maintains creator intent while dramatically improving compression efficiency. So the gains on some titles can be dramatic, and a publisher can decide whether they want to preserve grain or eliminate it. So if you've got grain from a high gain camera with video shot in the dark, you may want to get rid of all the grain. And if you're the director of a film like 300 comes to mind, where grain is used very heavily in the production, you want to preserve the look of that grain as close to the original as possible. But and I've had this conversation in depth with studio types. You're never going to get any grain out the same way that it went in on any codec. So grain management as a category is tremendously useful in any encoding. Unless you're in a studio with great lights and a great sensor, you're going to benefit from some of it. Now, adaptive use of such pre-filtering in an AI context is dramatically more effective because you can determine ahead of time, is this useful? Is this helping my outcome? And for some video, it matters a lot, and some it doesn't. Example I gave, webcam with low light, it'll benefit a lot. And wouldn't it be nice to have a way to make that determination using an AI instead of having to manually select that on every video? If you're doing user-generated content, for example, adaptive pre-filtering can be hugely advantageous.
Okay, so when you say adaptive, is that AI adaptive? So it's checking out the video?
Insofar as we're not applying it if it's not beneficial. And that determination is made by the AI.
And that is AI that you trained, or did it come from
It's another use case of VMAF.
It's still part of VMAF. So you're basically...
VMAF is just making this determination. Does this video look good or not, right? Are we hitting the threshold of can't tell the difference from the source? That's what VMAF is doing.
So what's the pipeline look like? I mean, what do you throw at the encoder? I mean, bitrate obviously is one obvious one, but do you throw other?
That's not. So we only use, in our recommended practices, we only use bitrate as a cap. So in the ladders that we advocate, that we sort of, if you want to use Codec Market 1 and leverage all of our best practices, you don't have to make any choices other than which codecs you want to use. But we will make a fully optimized multi-codec ladder with and without pre-processing, and try to hit a quality target for every step of the ladder instead of a bitrate target. So if we can do 4K video at 2 megabits a second, which we often can, we will. And if we need 8 megabits to get a good 4K video, we'll go that high. And if you don't have the bandwidth, you're not going to go that high. But a premise that we apply to every encode we do is we don't want to use more bits than you need.
It's kind of irrelevant whether you're adjusting the bit rate or not. The bit rate's getting adjusted. I mean, so you talked about adaptive pre-processing. What other encode parameters are you adjusting based on your determination with AI? I mean, you've got bit rate, you've got the pre-filtering you talked about. What other parameters are you adjusting within the encoding that you're making for the encoding ladder?
I mean, that's different per encoder. Most of the adjustments are made for things other than quality, such as seekability and so on. Some people might like shorter GOPs, some people like longer GOPs. But the main parameters that are being adjusted for compression efficiency gains are adaptive preprocessing and bitrate / quantizer targets.
When you talk about quantize, what does that mean? You know, I've seen a lot of, with a lot of other vendors talk about adjusting the quantization. What does that mean?
So there are different implementations of quality settings on encoders. X264 implemented CRF, which was sort of a game changer at the time, which was one of the first perceptual optimized rate control methods. That has been dramatically surpassed today. So one can get, if you don't have a external rate control method, using CRF on X264 or X265 is a great way to target a quality and let the codec choose the bit rate for you. Many codecs don't have this function. I'll point to the ASIC encoders as an example. There are a number of ASICs on the market. Different ASICs have different quality profiles. Different ASICs have different codec profiles. Some of them only allow you to choose a quantizer, which is it's usually called the Q function in FFmpeg, which is just the level of compression that it applies. And that's different from choosing either a quality or a bitrate target. It's just literally the amount of compression that's applied.
Okay, so quantize means compression. Which codecs are you deployed with initially?
We're focused on the free ones, but we've implemented free and non-free codecs. So we have integrated, of course, H.264, H.265, excellent suite of codecs that came out of Google and the Alliance for Open Media, VP9 and AV1. We're big proponents of AV1. And we have also integrated and are quite fond of LCEVC from our friends at vNova, which interestingly applies to each of those codecs I just mentioned.
Right. So when you talk about the quality advantage you're getting, how would you quantify that for, let's start with H.264. Janos are encoding H.264 using the X.264 codec with FFmpeg. How much better, and I'm doing a straight 3.5 megabit per second encode, how much better are you going to get? I guess it's going to be content dependent. I understand, but what's your big claim?
How are you asking versus just straight invocation of x264 on a command line? What can we get?
Correct.
So of course the answer to that question
It
determines
depends.
how you're evaluating that. So if your gold standard is VMAF, then the answer to the question is we will what you'll get if you do a CRF encode, or you said a 3500K encode, is a video that has a varying quality level throughout the course of the content. And if you apply that same bit rate to a variety of different encodes, you'll always have videos that are encoded with either too many bits or too few bits. It'll either be well above the threshold of being able to perceive the difference, which in VMAF we call VMAF 94, or below, in which case the video will not look as good. What we enable somebody to do is say, I want the video that I get out of this platform to look as good as the video coming in, where majority of my audience can't tell a difference. Or you can set it to some reasonable threshold below that, which using metrics that come out of the mean opinion score construct of the metrics are I can't tell a difference, or I can tell a difference but it's not offensive, or this looks bad, right? 1 through 5. And I've actually done one of these mean opinion scores. It's a very time consuming process. You got to buy a lot of pizza and coffee for a lot of people. It takes a long time. It's really remarkable how closely FFmpeg gets to that. So by taking this approach compared to what you do on a command line, the answer is you can get gains of quality and efficiency that are quite substantial, certainly on the order of 30% or more.
Okay. What about CRF? If I just do a straight CRF 21 encode, the bit rate's going to adjust up and down. You do CRF, I do CRF. How much better is your encode going to be?
Well, so if we're just talking X264 here, you can get most of the way there with CRF. CRF 21 does always give good results and is always efficient with video. So I would say if you were just doing H.264, setting a CRF 21 will probably get you within 15-20% of where we can be with the optimizations that we're talking about.
Okay.
Not including adaptive preprocessing. With adaptive preprocessing, we can get as high as 50-60%.
Well, what are the other modifications that you're doing? Because you've talked about adaptive preprocessing. I get that, but you've got X264, I've got X264. What else are you doing for the 15-20% that you just mentioned?
Oh, again, the short version is VMAF targeted encoding will get you better, will ride you closer to that threshold of perceptible difference than CRF will by about 15%. So
okay, so you're saying
so
VMAF...
you can modulate the bit rate more tightly to that threshold of perceptual difference, which is going to give you a quality curve that if we go all out and do per scene optimization, you'll be closer to a perfect encode all the way through. Again, CRF 21 does a fine job. CRF 21 is not available in the new codecs. So keep in mind, X264 is a 20-year-old codec now, and there are huge gains to be made moving to new codecs. New codecs don't have CRF. And that's because the folks that have developed those and are using those have other more sophisticated means of doing rate control. And they're not using CRF, right? They're not leaving it to the codec to make these determinations.
Okay. I mean, we'll talk about the hardware you're using in a moment, where the hardware that I'm familiar with does use CRF. How are you using VMAF as it relates to rungs below the top ladder? VMAF is easy, top rung, 94 to 96, you're golden. What about your 720p rung and your 540p rung and your 360p rung? What targets do you come up with there?
So the specifics of the convex hole optimization that we've done are, I don't think it's easy to just map out the VMAF values for you, but our goal is to set a maximum of, our recommended practice is to set a maximum of 94 at whatever the top rung is, and then to evenly space as you go down, right? So um, generally, we're looking to get our viewers to that top rung as quickly as possible. And for the most part, because we are doing such an efficient job overall of encoding and using new codecs, we get 95+% of our audience there. And the other steps down the ladder, which will go down as low as VMAF 50 or 40, are just to make the smooth transition in bandwidth outage situations.
Okay, so I guess the quick answer would be that you're figuring out what the convex hull would look like, and then there's an optimum quality that you can achieve, and you're getting as close to that optimum quality as you can. Is that fair?
We set the crucial, the thing that has most impact on what somebody's spending and how large an audience somebody can get is where they want to set that top rung. The top rung that we advise is a VMAF 94 at whatever the top resolution is. So if it's 1080 or 4K, that's the top rung.
Okay.
And going down the ladder, we just try to evenly space it to cover the bandwidth range that one can expect with. I give an example of we want to make sure that even the person who's in an elevator in New York City on a lousy budget carrier is going to have some experience.
Okay. Don't want to piss off those New Yorkers in elevators. What hardware are you using? What's the accelerated portion? Who's supplying that?
So we have implemented a few. There are some excellent options out there. What we've implemented first is actually from Intel, because Intel supports VP9, which we think is an important codec. They do a great job on H.264. They do a great job on H.265, and they do AV1. At the moment, we're using that for folks that want to fast encode. To date, neither of the ASIC encoders that we've found have done as good of a job as the respective software encoders in terms of maximum ultimate quality that we can get, but they do offer great cost and speed efficiencies. So for user-generated content folks going for multi-codec in large volume, it is an excellent choice. We've also evaluated technologies from NetInt. We're interested in evaluating the latest from AMD, NVIDIA, and so on. Each have strengths and weaknesses and a different set of codecs that they support.
So how are you charging for this?
Depends on the size. It depends on the size of the customer, but we have worked with folks that are publishing tens of videos a day and folks that are publishing tens of thousands of videos a day, and we have different pricing models for each. Generally, it's based on the compute that we're doing.
As opposed to minutes or hours of video? It's
correct.
You've got a... Okay, that's kind of the hybrid model, I guess.
And the reason for that, as you can deduce from this, is we're giving people a wide range of options on how they process the video. Some are much more compute intensive than others. But we have... My background, as I think includes building pipelines for some really large user-generated content sites for whom cloud offerings have been cost prohibitive, and having a wide range of options and flexibility for folks at different points of scale is our strength.
Okay. What does LCEVC bring to the table? And
mostly it brings a really elegant backwards compatibility solution. We think it's an excellent option for folks who have large libraries of video and or a strong need to operate with legacy infrastructure. So what they're doing with terrestrial broadcasters, allowing a single channel of video to do both high def and 4K is sort of amazing. So they have sort of reuse of either the storage or the bandwidth is really where it gets interesting. So you can have the H.264 baseline and then the LCEVC enhancements as two separate payloads, either on disk or on the network, and one enhances the other. So it makes sense for folks, if you think about folks that have just a massive library of content, for whom multi-codec might be cost prohibitive. It's a great option.
Where does it play, though? There seem to be not a lot of players that are, I mean, I realize everything's backwards compatible depending on the base layer codec you use, but where does LCEVC, the enhancement layer, play at this point?
We've got it working on PCs and on Android phones and on iPhones.
When you say we've got it working, are you supplying playback services as well? I mean,
Codec Market does end-to-end integration, including but not limited to back-end encoding, storage, CDN, and player. So we're not offering a player, but we've partnered with the major player providers, and there's more than one that works with the LCEVC.
Right? So the customer goes to vNova, gets the licensing in place, and then comes to you, or I guess it doesn't matter who they go to. They can get a player once they have the license, and they can deploy it at will.
Yeah, not every player will work with it, but there are multiple players that will. So
understood.
We can
assist. I saw you
with...
have an agreement with Theo, and there's certainly one that does.
Yeah.
How long have you been in business?
Codec Market is a new company as of we did a soft launch with a large user-generated content site only servicing their needs initially starting in 2018, processed tens of millions of videos for them, and have been hard at work making the innovations and scale factors that we built for them. And unfortunately, can't, due to confidentiality, can't share who that was. But what we are now doing is taking that capability and making it available in a Web 2 API-like model to a broader audience. And among the things we're going to be showing at NAB are tools that allow even a small publisher to take advantage of those capabilities.
Okay. Have you gotten any third-party validations of your quality claims, University of Moscow or any other similar types of comparisons?
We have not, but I would love to.
Let me think.
I will say that the pre-processing technology that we leverage today was used by Deluxe and NBC Universal for many of their titles published on the Amazon Prime platform. And that technology is a very mature technology that's been sort of in-house in my prior companies and is now being leveraged by Codec Market. So that's not a new technology. That's not a new technology, but it's a very mature technology.
Is that open source? Is it internally developed?
Proprietary. It's proprietary.
Okay. So I spoke with companies like Digital Harmonics with their keyframe and with VisualOn with their optimizer. Is that something similar to what they're doing? Are you familiar with them? I'm
not.
Okay. It's a pre-processing technology that they claim can deliver somewhat, with the optimizations can deliver somewhat close to what you're talking about.
Yeah, there are other companies doing similar things. And without naming names, I can tell you that the large user-generated content site that we worked with did evaluate some of the others and shared the results with me, and ours were quite favorable. That was one of the reasons they worked with us.
Any big customers you can mention or identify?
Unfortunately, not yet.
Okay. So just kind of to summarize there's essentially two things you've talked about. You've talked about using VMAF in an efficient way to direct your encoding decisions so you can get very close to the convex hull. And you're saying that's 10 to 15% better than what you could get with CRF encoding. And then there's the optimization technology, which is optional, that gives you, I think the number you mentioned was up to 60% more. Does that summarize what you're doing?
Yes, but I want to point out, Jan, that not everybody has the expertise that you have implemented in a high capacity transcoding pipeline. And um, what I think is really interesting is that the dominant platforms that are doing encoding today are not at that level of sophistication. So what we've found, which is I think just measure the fact that most folks are not Janos and most folks are not employing a couple hundred compression engineers. The gains that we make over the starting point of folks who are using, and again, I'm not going to embarrass folks by naming names, but major cloud providers, folks that are using very large, very robust services from major cloud providers, multi-billion-dollar companies, are getting much worse results than X264 CRF21, much worse, and I would say are wasting closer to 50% of their budget for storage and bandwidth on lousy decisions that are made by these dominant transcoders. And I've got a thesis as to why that is, which is that these companies that are offering these services are making their money on storage and delivery. So why would they want to do a good job of encoding video? Why would they want to exhaust every possibility to squeeze a little bit more efficiency? The answer is they don't. The answer is they want to keep 1080 H.264 at 6 megabits. You and I both know we can do most 1080 videos today, even with 264, can get by with 2 megabits and look great. That's not what we're seeing from these major platforms. So I don't think that your assertion that most folks are going to get 15% benefit is even close to what reality. I mean, we're seeing folks that are getting greater than 2 to 1, and when we're talking 4K, more like 3 or 4 to 1.
Okay.
Regularly, and coming from major cloud providers. So again, you can't assume that people are already implementing best practices. So I mean, honestly, if I were to summarize what you get working with Codec Market, is simply the best of the best of the best, implemented by folks who know what they're doing, and just by making all the right decisions and then having an AI validate those, the gains can be quite tremendous.
Okay. You going to be at NAB?
I will.
Okay. In a booth, or where can people find you?
We're actually going to be showing with the VNova folks.
Okay. I'll come by and I'll say hello.
Excellent.
Daniel, thanks for your time. Good luck. And I'll see you in a few days.
All right. Excellent. Thanks, Jen.